There are even many atheists and naturalists who think that we just can't say whether there is life after death. There's no evidence one way or the other. So I want to tell you that we can say that there is no life after death. Sorry. Why is that true? Well, there's an argument. The argument is basically the following. The mind is the brain. That's what the mind is. There's nothing else other than the brain that is going on. Thank you. Brain fans, I like that. The brain is made of atoms. Any Atoms fans here? Atoms, yes? Woo. Good. All right, here's the controversial one. Even my friends get annoyed when I say this, but it's the truth, so I will lay it on you. We know how atoms work. They're not a mystery to us. And they work in such a way that when you die, there is no way for the information that was you to persist after death. There's no way for that stuff, that knowledge, that set of beliefs and feelings that made you to leave your body, because it is stuck there with the atoms that is decaying in your tomb or being cremated or whatever your favorite way to be after death is. So I want to emphasize, I want to make a little bit of an argument, a very, very, very little bit of an argument for the statement made in red that we know how atoms work. The point is that the laws of physics, we don't know all the laws of physics by any stretch of the imagination, but those laws of physics that are relevant to the atoms in your body, we know all of the laws of physics that far. There's no room for new laws of physics that would affect how the atoms in your brain actually work. That's a very subtle statement. So I could, I think that Dan mentioned I had 3 hours to give this talk, but I would get tired if that happened. So I would give you the whole explanation for the laws of physics, how they came to be, why we're confident, but instead I will just intimidate you in submission by showing you an equation. So in this one equation are summarized all of the laws of physics necessary to understand the atoms in your brain at the energy, mass, and length scales relevant to your everyday lives. We have quantum mechanics, we have space-time, we have gravity, we have the other forces, electromagnetism and the nuclear forces, we have the matter, the electrons and the quarks of which you are made, and we have, of course, the Higgs boson we discovered. Higgs boson fans also, 2 years ago. The point is, again, there's plenty of room in the laws of physics for other stuff. We don't know how black holes work. There's plenty of things we don't understand. I'm not saying that physics is done. I'm a physicist. I know it's not done. I'm not going to retire soon. But we know enough to say that if there are any other forces, particles, fields, phenomena, they can't affect the atoms in your brain, because either they're so weak that they would have no effect on what the atoms are doing, or we would have found them in experiments. Those are the only two options. So no one ever understands me when I say this, so I'm going to say the same thing over again. Here are the caveats to this statement. I'm not saying we understand all of physics. I'm not saying that there's room for no new discoveries in the non-everyday world. I'm not even saying we know how the fundamental laws come together to make complicated macroscopic things like frogs and ecosystems and spiral galaxies. There's enormous amounts of work to be done in understanding how science works. But we have an underlying framework, which we call quantum field theory. And quantum field theory is either true or false. All the evidence says that it's true, and if it is true, then there is no room for new physics that can in any way affect what goes on in the atoms in your brain. We understand what they do. There is therefore no room for the information that is you to persist after you die. What are we to do with people who say that they have evidence that there is life after death? I like to put it in terms of two options, and either one you are allowed to choose, but you should know what options you're choosing. Option one is that some ill-defined metaphysical substance not subject to the known laws of physics interacts with the atoms of our brains in ways that have thus far eluded every controlled experiment ever performed in the history of science. Or people hallucinate when they're nearly dead. But going beyond claims of people who have actually visited heaven and come back to sell books about it, because that's the mission that they were given, we can be scientific about this. We can ask, okay, given that we're made of atoms and we understand what the atoms are doing, what is life? What is this complex, non-fundamental phenomenon that arises out of the motions and interactions of the fundamental particles of which we are made? And this guy, Erwin Schrödinger, famous Austrian physicist, he was one of the very few, well, there are many, many famous physicists who fled Austria and Germany just before World War II. Most of them fled either because they were Jewish or their friends were Jewish or they were appalled at Hitler's treatment of the Jews. Schrödinger fled because he was having trouble keeping his mistresses. And he tried to get a job all over the place, and finally in Ireland at Trinity College, they said, sure, well, yeah, no problem. So he moved to Ireland and became a biologist, and he wrote a little book called What is Life? And this book became quite famous because he prefigures a lot of what we soon thereafter discovered in terms of DNA and the genetic code, just by the basis of thinking like a physicist. But he also tried to address the question in the title of his book, what is life? When is a piece of matter said to be alive? And it's a wonderful, thought-provoking answer. Basically, he says something is alive when it keeps moving long after it should have stopped. That's what it means. If you have a little chicken, baby chick, grows up to be a chicken, as long as you feed it, it's going to move around. It's going to flap around and raise its wings and so forth, cluck. When it dies, it will stop moving. It will decompose and will return to the ground. And so Schrödinger wants to know, what is going on? What is it that keeps alive things moving and walking around and making noise and raising a fuss? And the answer, as he quite correctly puts it, is my favorite law of physics, the second law of thermodynamics. Second law of thermodynamics is this is not the same chick that was on the cover. Death. What can you do? The second law of thermodynamics is the law that says that the entropy of the universe, or of any closed, isolated bit of the universe, increases as time goes on. Entropy is simply a measure of the disorderliness, the messiness, the chaotic nature of stuff. If you start with an unbroken egg, it is easy to break the egg. That makes it more disorderly and disorganized. It is easy to turn that broken egg into scrambled eggs. Again, more disorganized. It is very, very difficult, and would never happen by itself, to take the scrambled eggs and make it back into the pristine form of an unbroken egg, Humpty Dumpty notwithstanding. So this law is very, very profound, and it captures people's imaginations at a sort of social and personal level as well as a scientific level. It also captures the imagination of creationists, because they say, look, there's a fundamental law of physics. You're telling us one of the famous laws of 19th century science says that things run down, that things become less and less organized over time, that ultimately the universe will reach heat death. And yet, you expect me to believe that all of the marvelous complexity of life and the biosphere and evolution that you guys talk about all just happened here on Earth, starting from some disorderly primordial goo. How is that possible? Now, there's two answers to this. One is the simple and perfectly correct and short answer, which is isolated systems, we said. And the Earth is not an isolated system. The other answer to the creationists is a more subtle one, which is to say, you're right. It doesn't seem to violate the letter of the law, in terms of the second law of thermodynamics, for life to arise on Earth, but does it violate the spirit of the law? Why is it that complicated, elaborate, complex organisms arose just through the impersonal working out of the fundamental law of physics if there was no guidance there? If anything, the tendency seems to be towards messy disorder. And so here's the Earth, there's a picture drawn by a famous artist named Roger Penrose. And what you see is that the sun is a hot spot in a cold sky. If the whole sky were the same temperature as the sun, the Earth would get a lot more energy. Energy is good, but the Earth would soon come to be the temperature of the sun and we would all die. If the whole sky were the temperature of the night sky, the Earth would come to be the temperature of the night sky and we would all die. The reason why we are here and life arose on Earth is because the sun is a hot spot in a cold sky, and what happens is we get low entropy energy, orderly energy from the sun that is able to do useful work. We chew our cud and we photosynthesize and we have conventions and we degrade that energy. We raise its entropy and then we send it back to the universe. For every 1 photon of light we get from the sun, we radiate back 20 photons back into the universe, 20 times the entropy, 1/20th of the energy per photon. We give exactly as much energy back to the universe as we get. The sun is not useful as a source of energy, it's a source of low entropy energy. And the thing that we do with that low entropy energy is we make life and do what life does. This is the thing that in the audience, when I was debating Eben Alexander and Raymond Moody, that the audience who were not on our side, Steve Novella's side and mine, the thing they didn't get the most was, but when you die, where do you go? Isn't energy conserved? Don't you have energy in you? Doesn't it go somewhere? And the answer is that life is not an energy, a force, a spirit, a substance. It is a process. It is a chemical reaction. And the end of a life is putting out a candle. When you put out a candle, the energy doesn't go anywhere. The reaction stops. When you die, you don't go anywhere. Your atoms are still there, but you stop happening. That is what it means to die. Roughly speaking, it's very, very possible, by the way, that medical science here on Earth will extend our lives by an enormous amount. It's not at all in violation of the laws of physics for human beings to live thousands or tens of thousands of years. But we're not there yet. We don't have that. We, like other mammals here on Earth, get roughly 1.5 billion heartbeats per lifespan, and then that will be it. We will go away. It's a mistake to think that there is some perfect way to be. This is the lesson of our ephemeral, entropy-driven lives. So it's not just heaven is a bad idea, happiness is a bad idea. Now, don't get me wrong, I like happiness, I try to get it myself, I'm kind of happy. What I'm against is fetishizing happiness. If you go to the New York Times bestseller list, if it's not proof of the existence of heaven books, it's happiness books. Not a lot of cosmology books on there yet. The point is that we make a mistake because we think that there is some way to be, some situation we can put ourselves in when we reach perfect happiness and then we'll stay there forever. And then that would be like heaven. But the nature of life itself is movement and change and evolution. There can't be a perfect state of being. And there's science behind this. In psychology, they talk about the hedonic treadmill. They do studies. They study people, they measure their level of happiness before and after some life-changing event. If you win the lottery, you become happy, but a few years after, you're the same level of happiness you had before winning the lottery. If you get in a terrible accident and become paralyzed and paraplegic, you become unhappy, but a few years later, you're the same level of happiness you had before the accident. And you can talk about the chemistry of it, and the dopamine is flooding your brains, and you get used to that. You want more dopamine, and you can't get it. But it's just all based on a fundamental flaw. There's no way to achieve this perfect, everlasting, never-changing happiness, because if it's never changing, that's not that interesting, and it won't make you happy. It's a fundamental contradiction. Most of us choose to be a little bit more coarse-grained, to tell a story about who we are and how we got there. And it's that story that gives meaning and success to our lives. It's not the attainment of any one state of being where we get there and we stop. It's a story with a beginning and a middle, and inevitably, according to the laws of physics, an end. And how well that story is, once you're done telling it, is the measure of success of your life. And I say this, and I don't want to belittle the very, very real sorrow that accompanies death. I don't want to make light of it. I think that, we all have friends, family members, loved ones who have died, and it makes you very sad, and that's not a mistake. It is sad when we lose someone that we care about. It's okay to feel that sorrow, to cry, to have whatever reaction you want to. Knowing that it's inevitable doesn't make the sorrow go away, but maybe it affects how you deal with that sorrow. The point is that death is serious. It does happen. It's okay to treat it seriously. But the reason why it's serious is because life matters. Because the life we have right now is not a dress rehearsal. It's the only performance we get to give. I'll end with this picture, which is the favorite picture. I always say that if I ever work up the courage, someday I will give an hour-long talk which consists of me asking the lights to go down in the room, putting up this picture, and standing there silently for an hour as everyone contemplates this picture. The universe can be kind of overwhelming. We are very, very small. We are a very, very tiny part of the universe, but we are a remarkable part. We are just collections of atoms, but we are collections of atoms that have attained the ability to think about ourselves, to reflect about the world that we live in, and to write our own stories. Our lives will not last forever, and that is what makes them matter so much.